So let's start today's topic. So the topic is contour milling. First of all, what is contour milling? So contour milling means, again, let's say this is your workpiece. So you will machine like this outer or inner, like a profile, or we call it as contour. So machining outer or inner profile, that is what is called the contour milling. So the advantage is that, so in this case, what is the shape? Outer shape, it will be like a rectangle, right? So rectangle, square, circle, arc, uh, any complex profiles we can machine using this contour milling technique. In contour milling, we have mainly 4 cycles. One is new contour. New contour means you can define the shape, or you can define the profile. For example, rectangle, arc, circle, arc, line, chamfer, radius, complex, shape. So using all those, you can create a new contour. So for example, like this, you can create an arc. Like this, you can create a contour. So the advantage of new contour is that you can create a new profile. You can draw a new profile. As per the CAD drawing, you can create a new contour. This will be the basic form in pocket milling, path milling, etc. Say, for example, you have a, so like this, just imagine. So this is a profile consisting of line and a arc, right? So like this, you can create different profiles. Then path milling. So path milling means, so once you prepared your new contour, okay, so for example, this case, okay. So next is tool will follow this path, right, to machine this profile. This is what is called a path milling. So tool will follow the path of the contour and it will remove the material. So we can remove material from outside, we can remove material from inside, complex shape milling, we can finish machining, etc. Then we have a rough drilling. So rough drilling means before starting large pocket or a closed contour milling, we will remove material using drill. That is what is called a rough drilling. This will reduce the tool cutting load. So the use is that before machining a deep pocket, or if you are going to remove large amount of material to reduce tool wear, etc. So for example, you have a task to prepare a 50 mm pocket milling, 50 mm pocket milling. So before doing this 50 mm pocket milling, first we will prepare a 20 mm drill hole. Understand? So that we can reduce the what cutting load. And then finally we have pocket. So again, this is based on the contour. Pocket means it will be like a closed profile, like this inside, like this. So we will remove material uh, like this closed profile. Inside this closed profile, we will remove material, that is what is called pocket milling. This is suitable in die and mold machining, fixture plate, component recess, housing pocket, etc. So the procedure will be like this in contour milling. First, you have to define a new contour. Okay, so using new contour, create a shape, right? Then if you need a rough drilling, you can do rough drilling to remove some material before doing the actual machining. Actual machining means pocket milling or path milling. Then after that, using pocket milling, the inside material we can remove, and the path milling we can create material. Uh, Tool will follow the path of the contour. That will remove the material. So using path milling, uh, we can remove material and we can finish the final profile. So for example, let's take, I will give you one example. Okay, so you have a plate. So this is an aluminum plate. Okay, just take this example. This is an aluminum plate of 80 by 50 mm. So first, you have to develop a new contour like this. Okay, then after that, sorry, sorry. Yeah, this is our plate. Okay, this is our plate, and here I'm going to create a pocket of 80 by 50. My task is to prepare a pocket 80 mm by 50 rectangular pocket. First, I will use rough drilling. Okay, I will drill a hole. Then after that, using pocket milling, I will remove the material, and finally using path milling to finish the pocket boundary. Okay, so we can let's see more information about new contour. So create new contour means we can create a 2D profile. We can create a 2D profile, or we call it as contour. So this contour we can use for path milling, pocket milling, or any other contour machining cycles. So contour, what do you mean by contour? For example, a contour means consisting of, so see, for example, this is a contour. So a contour consisting of line, arc, right? So this contour consisting of line and arc only. So we can create geometric shapes using these arc, line, circle, chamfer, etc. So the procedure will be, first you have to go to contour mill and you can create, so you can click a new contour. So for example, in this case, here, go to contour mill and then after that click new contour. Then after that you have to give a contour name, for example, plate profile. Okay, so I'm going to give a name, plate profile. Plate profile. So I have given a name, plate profile, or you can give a pocket on, etc. And after that, click accept. If you give if you give a name and that name is already there, then the controller will give you a message. Program name already exists. You will get an error message. So you then in that time, in that case, you should give a new program name. So after that, you have to give the starting point. Say for example, so after this start point, See, what is the start point? X equal to 0, y equal to 0. I can give, say, x equal to, see, absolute value. What is the starting point? X equal to 0, and then y equal to 0. So if needed, you can add a G code also. Okay, so for example, G17, G90, G54, etc. If needed, so this is what is called, so this is plain selection, this is absolute programming, and this is work offset. Then after that, press the accept button. If you press the accept button, it will add to the contour. Okay, accept. So first of all, you should give the starting point. Okay, what is the starting point? X0, Y0. Okay, give the starting point X0, Y0. Okay, and then after that, press this accept. So it will be added to the contour program. Then after that, you can add elements, contour elements. You can add geometry elements. So for example, straight line element. So say for example, the starting point is 0, comma 0, right? Then after that, you can give a straight line. So straight line will be say 100, comma 0. So this will give you a line in the x direction. So tool will move in this x direction, right? So I will be using this line. So x will be 100. X will be 100. Okay, starting from 0.0. Okay. Starting point will be 0. Then you can select the line. So x equal to 100. Okay. Then after that, we can select straight line y. So, so starting point 0, 0, right? Then 100, right? 100, 0, right? Okay. Then straight line Y, and I can give say straight line Y. So straight line Y, right? So in XY, straight line XY means if you give say if so straight line, say this one you can give 150, 100. Okay, so let's see this one. So 150, say 100. In straight line, you can give a radius say 20. 150. Starting point 0, 0. Okay, accept. Then selecting straight line X. Okay, then next I'm going to discuss what are the parameters, straight line X parameters. Okay, so the straight line X parameters will be here you can see X. So X means, so what is X? So X means the endpoint. So for example, starting from 0, 0, right? So the endpoint X means, say for example, this line is 100. So X will be 100. You have to enter X equal to 100. Then this we have alpha 1, right? So this will be the angle from the starting point. So say for example 0 degree. So 0 degree means positive x direction, right? So this will be positive x, right? So this is 0 degree, 90, 180, and 270, right? Then we have okay, so let's see this one. So x is 100, so alpha 1 is equal to how much? In the 0 degree, you cannot change it because x equal to 100, right? You can set it. So alpha 2 means angle to the previous element. Then transition to succeeding element. How you can go to the next line? Okay, transition to the succeeding element. How you can go to the next line? Okay, so we have two methods. One is radius and the second one is bevel. So radius means the corner will not be sharp. It will be like a corner. Say for example, radius 10. Okay, it will be a 10 mm radius. So bevel means it will create a chamfer. Say if you give 5, bevel means it will create a chamfer. Say 5 means chamfer. So transition to next element means how you can go to the next line. So for example, uh, we can click radius. Okay. So radius you can give us say 10. Click accept. Yeah, see this. So here you have created an arc, right? Yeah. So in this way you can connect. So for example, you have a point, starting point, then you can go to this direction. Here you can create an arc. So like that it will continue. If you give chamfer, then it will be like this. So additional commands here you can add the G commands okay, say for example G41 you can add commands. So the left side, okay, in the left side, the left side of your screen, the contour elements will be displayed. in the order. So for example, here in our case, we have our starting point, right? So this is our starting point, right? Then we have a straight line X, okay, with a radius 10. Then after that, we have a straight line Y. Here we have a radius of 10, right? So, so the contour elements will be shown one by one in a proper order in the left side of the screen. Then coming to straight line Y. Then coming to straight line Y. So using straight line Y, so for example, we have our starting point. Okay, so this is X, right? And right now this is our position. So from this position, we can create a line like this in Y direction using this straight line Y. So you have to enter the Y value. What is the Y value? Y means the endpoint, absolute or incremental. So Y represents the endpoint. So for example, this length is say 100. So y is equal to 100. So or it is 80. So Y is equal to 80. Then we have alpha 1 and alpha 2. So alpha 1 is equal to, so alpha 1 is equal to 90 degree because it is alpha 1 is equal to how much? Alpha 1 is equal to 90 degree, right? Because this is 90 degree, right? See, for example, in this case, you can see. So alpha 1 is equal to 90 degree. Then alpha 2 means angle to the previous element. Okay. So the previous element was, so this is our previous element, right? So this angle is how much? 90 degree. So angle to the previous element is also 90 degree. So alpha 1 is equal to 90 degree, alpha 2 is equal to 90 degree. Okay. Then after that, transition to the succeeding element. How we can go to the next element? Okay. So for example, in this case, I need a chamfer. Okay. So I'm using chamfer. Say, yeah, 10 mm chamfer. Okay, if you give radius, then it will be the corner will be around like a shape, 5 mm radius. If you give bevel, it will be a chamfer. So this will be 100 absolute. So here, see, so we started from here. Okay, starting point 0. Then we have this is equal to 100. Then this is equal to, here is equal to, from here it is equal to minus 100. So you can add additional commands also. Then next is straight line XY. So straight line XY means you can use X and Y coordinates at the same time. That means this is used to create a diagonal line. Okay, so for example, this is the starting point. If you need to create a diagonal line, you should give the X value and Y value. So this straight line XY is used to create a diagonal line. Okay, so in this case, we have a X and Y. So X means the endpoint X and Y means endpoint Y. So L means what is the total, L means what is the total length of the line. L means what is the total length of the line. Then we have alpha 1, that will be the start angle, and alpha 2 will be the angle to the previous element. Then again transition to the succeeding element, we have radius and a bevel. If it is radius, you should give the radius value. Bevel means you should give the chamfer. If needed, you can add additional commands, additional G-code commands. So in straight line XY means both XY will change. But in previous straight line Y means only Y value only will change. So if you use straight line Y, you will get a vertical line only. If you use straight line X, you will get a horizontal line only. If you use straight line XY, you will get a diagonal line or an inclined line. So straight line X, straight line Y is used to create rectangle, right? Then if you need to create some complex contour, you can use straight line XY. Straight line X, straight line Y will be simple contour, whereas straight line XY will be a complex profile. So next is contour element circle. So contour element circle is used to create, circular shape, or you can create arc. So in SHOPMILL, we can create circle or arc using this contour element circle option. So that means if your object is having some radius or rounded corner or some full circle or arc profile, so you can create these type of shapes using this contour element circle. So here you have to define the direction of rotation. Okay. So tool in which direction? Okay. So that means in clockwise direction, or that means direction of rotation right. That means clockwise direction and counterclockwise direction. So clockwise direction means this is equal to G02 and counterclockwise is equal to G03. Then we have a radius R. Okay. So radius R means what is the radius of that arc? 20, 25. So for example, you have an arc. So and the radius is equal to 25. What is the radius of the arc? Then we have XY coordinates. So XY coordinates means where this arc. So for example, this is the starting point of the arc. Okay. So where this arc will stop. That is what is called XY. Say for example, X0, Y0 you can give. So tool will end here. Then we have I and J coordinates. I means this represents the uh, center point of the circle. So for example, so this is the center, right? So I means X direction center distance. J means Y direction center distance. That is what is called I and J. Then we have alpha 1 and alpha 2. This is alpha 1 means it is the start angle from the positive x-axis. And alpha 2 means angle to the previous element. So this alpha 2 will give you a smooth transition. Then we have beta 1 and beta 2. So beta 1 means where this arc will end. Say for example 180 degree. You will get a half circle. Then beta 2 means how much degree this arc will open. 90 degree, 180 degree, half circle, full circle, etc. Again, you have transition to succeeding element. We have radius and level. If you give radius, it will give you 5 mm radius, and the chamfer 3 will give you a 3 mm chamfer. Additional commands you can add if needed. let's see what are the other functions. So we have change view. So change view means you have a graphics window and you have input screen, right? So by using this, you can see the contour as well as you can edit the parameter. Then we have tangent to previous element. So this will be, for example, we have previous line or previous arc. Okay, so the element will be add a tangent to the previous element. So using this, we can avoid sharp corners, so we will get a smooth curve. Then we have dialog selection. If we will be using one parameter, so sometimes using one parameter, we can create two different circles. So control will show those two. So operator can choose which one is okay. So operator can select the appropriate one. Select dialog again. This is to change the previously selected circle option. Display additional parameters. It will show additional parameters such as additional G code, transition settings, advanced options, etc. Then close contour. This is a very important function. If you select this, it will go to the from the uh, last position to the starting point of the contour. Okay, it will automatically create a straight line. So in that way, the contour will be closed. So in pocket milling, we need a closed contour. So for example, you have a rectangle. Okay. You need to change the corner to rounded. So line, circle, R20 line. So using the circle element, using 20 mm radius, you will get a rounded corner. Then we have the symbol representation of the contour elements. Symbol representation of the contour elements. So in SHOPMILL, you are going to create contour, right? Every contour element will be having a symbol. So using this symbol, you will be able to easily identify and read the program, correct the program very easily. So for example, this symbol. So this symbol represents the starting point. So here you can see this circle with a cross. This symbol represents, this will give you the starting point. So this will be the starting point of the contour, right? And then we have a straight up, straight down, like this, straight up, straight down. So this means uh, straight up means tool will move in positive y direction. Straight down means tool will move in negative y direction. So this one. This is tool up, right? This one. Then we have we have this one. This one means straight left. So straight left or straight right. That means straight left means tool will travel to the negative x direction. Straight right means tool will travel to the positive x direction. straight line anywhere. Okay, so this represents the diagonal line, this one. This represents the diagonal line. Then curve right. So curve right represents the arc. Okay, so curve right or curve left. Curve right represents. So curve right represents, curve right represents, clockwise arc. Okay, or curve will be shifting to the right side. Okay, right. So, so this curve left. So curve left means counterclockwise direction, or it will be shifted to the left side. So here you can see this is curve left, right. So this is curve left means the arc will be in the counterclockwise direction. The arc will be in the counterclockwise direction. So that's it. And we have different colors. Okay. So here you can see this is our contour and we have different colors, right? So different color means we have a black, orange, and a line dot dot. So what is the meaning? So black means this is the final geometry. So black represents this is the final geometry. Okay. So orange line, orange means this is the right now you are going to. So for example, if I'm selecting this, okay, so this geometry, black means this is the final geometry. This orange means right now I'm editing this. Okay, so if you select this, so right now this is my selection. If you select anyone geometry, any one contour, it will be shown in orange color. So by using this color, you can easily identify. Then line dot dot represents partially defined element. So that means contour is not completed. Then in the system, we have automatic scaling option. So automatic scaling means if the contour becomes big or small, so the coordinate system will automatically zoom it, and we can see the contour inside the screen. This is what is called auto scaling. So sometimes your contour will be very big, sometimes it will be very small. So based on your contour, the system will automatically adjust the zoom in and zoom out, and it will show the contour. So how we can machine this contour machining? So how we can create a contour machining cycle? So the first step is to define what? First step is to define your contour, right? And then second one, you have to select the processing cycle. You have to select the processing cycle. For example, path milling or pocket milling, etc. So next, how you can change a contour. How you can change a contour. So how you can change a contour? Once you prepared a program, uh, Once you prepared a program, you can edit that program later. So select the contour and for example, if you want to delete, just open the program, select the contour, press the delete. You have to delete once again. So next I'm going to explain the path milling. So now we have created a contour, right? So now we have created a contour, right? Okay, so for example, just now I'm going to 100 by 100 this one. Contour, contour, right? So I'm going to create point, right? Okay, and set. So 0, 0 will be the starting point. Okay, that's a 0, there is 0 starting point. That's it. Then we have this x, and then plus on the right. So then we are straight line y, then the right. So then x, 7 minus 1 minus, so, and then this one minus 1 minus, so minus 50, so this one minus 1. This one minus 1, so 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 next is what is called a path milling. So path milling means, so now we have created a new contour, right? So say for example, I have created a rectangular contour, right, or a square shaped contour, right? So tool will follow this path. Okay, so tool will follow this path, and machining this contour is what is called a path milling. So first you have to prepare the contour. Then after that, then tool will follow this contour. So this path milling will be used for profile milling, outer contour machining, inner contour machining, finishing, chamfering, etc. So the path milling parameters will be, say you have to mention the tool name. Okay. So for example, end mill 10, then D represents the cutting number. Then F will be the feed rate, say 250 mm per minute. S represents the spindle speed in RPM. V means constant cutting speed in meter per minute. So the processing will be three types: roughing, finishing, and chamfer. So roughing means large amount of material will remove. You will not get the final dimension. In finishing, you will get the final dimension plus you will get a good surface finish. Chamfer means it will create a chamfer on the edge. It will avoid sharp edge. Then processing direction will be forward. The forward means based on the tool, based on the contour, tool will follow the same path. Tool will follow the forward direction. Then we have radius compensation. Left means G41. So that means tool will follow the contour uh, to the left side, G41. Right means tool will follow the contour through the right side, G42. Off means there is no compensation. There is no compensation means, that means tool's center line will be used to uh, follow the profile. Z0 will be the reference plane. That means the starting point of the machining. Z1 will be the final machining depth. What will be the final depth? Say 8 mm. Dz means this is the maximum depth per pass. Say for example 2 mm. So the final depth will be, so just imagine the final depth is 8 mm. So if you give dz, first will be 2, then next will be 4, 6, 8, like that. U represents the allowance. Uz means the finishing allowance depth. After roughing, you have some amount of material that we will remove during the finishing machining operation. That is what is called a finishing allowance. Fs will be the chamfer width, and ZFS chamfer tool plunge depth. And UXY, again it is allowance, finishing allowance. This is related to the sides. UZ means bottom. Then we have approach mode. Approach mode, straight line. So straight line means tool will directly end up. Then quarter circle, half spiral entry. Then half circle, half spiral entry, vertical. Tool will directly go down. Then approach strategy will be axial and three-dimensional. Axial means only Z direction. Three-dimensional means it is the combination of X, Y, Z. So it will be a smooth entry. So R1 will be the approach radius. L1 will be the approach length. So withdraw mode, after completing the machining operation, we have options. Straight means directly it will come out, the tool will come out. Quarter circle means half 1/4 spiral exit. Half circle means 1/2 spiral. Vertical means vertically the tool will be coming out. So the withdrawal strategy will be axial. That means in a direction. Three-dimensional means smooth exit. R2 will be the withdraw radius. L2 will be the withdrawal length. So lift mode means after completing the depth pass, how much distance the tool will move, retract. After completing one depth pass, the tool will go to another distance, retraction distance. Okay, so that means a safety distance, reference plane plus safety distance. So it will be Z0 plus safety distance or by safety distance on or on retraction plane or no retraction. FR will be in intermediate retraction plane. That means after completing the depth pass, okay, where to position the tool. That is what is called a FR. So the part milling cycle will be like this. Say, for example, in this case, so this is my contour, okay? So just imagine this is my contour. So here we have a straight line, then a chamfer, straight line, then a chamfer. And here there is an arc, line, chamfer. This is my contour. So first you have to create this chamfer. After that, select the tool, okay? Then you have to give the feed, speed, etc. Then after that, you have to select the strategy. Is it roughing strategy or finishing strategy? And after that, select the radius compensation. Then after that, you have to select the approach mode. So after that, select the approach mode. Okay. Then give the final depth and doing the simulation. And then after that, check start the mission. If simulation is okay, then start the mission. So let's continue this path milling. So in path milling, you have okay. So in path milling, you have a contour like this. This is your contour. So tool will continue this contour and will remove the material. So cutting will be happening in multiple passes. The approach withdrawal strategy machine will follow. So after doing the roughing operation, some material will be balanced. So some extra material will be there. So during the finishing operation, it will remove the material so that you will get the proper dimension, proper surface finish, and good accuracy. So chamfering means during the operation, the workpiece edge will becomes chamfer. It will not be 90-degree, it will be like a 45-degree bevel. Then we have a approach and withdrawal mode. So for example, this is our contour, right? Before starting the machining, how the tool enter into the contour. And after completing the machining, how the tool will exit from the contour. So quarter circle entry, then half circle entry, right? Then straight line entry. Okay. So quarter circle or half circle you will be using, you should give the tool center radius. If it is a straight entry, machine needs how much distance the tool's outer portion from the contour. So mixed programming is also possible. So mixed programming means entry will be like a quarter circle, exit will be half circle, or entry will be straight, exit will be quarter circle. This also machine is allowed. Approach or withdrawal strategy. So planar approach, then three-dimensional approach, right? So planar approach means first depth, then XY plane. Three-dimensional approach means all the three axes X, Y, Z move simultaneously. This will be a smooth entry. Then withdrawal strategy again. After completing the machining, tool will be coming out of the workpiece in reverse order. Planar entry or planar exit, 3D entry or 3D exit. Also, we can use mixed strategy. That means entry will be planar, exit will be 3D. Path milling and center point path. So radius compensation of uh, tool center will be uh, tool center will be used to follow the contour. That means G40 mode. In that case, we can use vertical entry or straight entry. See, pre-drill contour pocket. Pre-drill contour pocket means in some milling cutter, material will not directly plunge into the workpiece. So we have to drill first. Then after that, milling cutter will be used to cut the hole. Okay, so next is centering cycle. So the parameter will be T tool, that is center drill. D means the cutting number, F means feed in millimeter per minute, say 120 millimeter per minute or millimeter per minute. S means spindle speed, say 2000 RPM. V means constant cutting speed. TR will be this is the main parameter. TR will be the reference tool. This will be representing the milling cutter to do the pocket clearing. Based on the center drill position, it will calculate. Z0 will be the reference point. That means the surface level where the machining will be starting. Say, for example, workpiece top surface. Z1 will be the centering depth, how much distance this drill should go. For example, 2 mm. DXY will be the maximum plane in feet, say 6 mm or 60%. UXY will represent the finishing pass, how much material we have to, uh, how much material remaining for the finishing operation, say 0.3 millimeter. Let's say 0.3 millimeter. So lift mode means, okay, so for example, if there are so many plunge points, okay, before going to the next location, next point, how much distance the tool will retract. This is representing the lift mode. So lift mode will be on the retraction plane. So after completing the centering, the tool will go to the retraction plane. Another one is Z0 plus safety distance. So we'll give Z0 plus safety distance. The tool will retract it this much level, and then after that it will go to the next point. This will be more faster than the retraction plane. Rough drill. Rough drilling means this is to remove large amount of material before starting the contour pocket milling. Okay. So we will be using milling cutter to remove the material, right? So before doing the contour pocket milling, first we will create a hole there. Okay. So that what will happen if you use the milling cutter, the load will be reduced, right? In this way we can reduce the machining time. Also, we can increase the tool life. This is what is called a rough drill. So the procedure will be like this. First of all, we have to create contour, then centering, then after that rough drilling, then pocket clearing, finishing. Again, we have the parameters such as tool name, cutting feed, spindle speed, cutting speed, TR, reference tool, right? So this will be used as milling cutter to do the pocket clearing. So Z0 reference point, Z1 pocket depth, DXY maximum plane in feed, UXY finishing pass, UZ finishing pass depth, lift mode after completing the one operation, how much distance tool will retract it. This will be to the retraction plane, or is it 0 plus safety distance. Then we have our mill pocket. So mill pocket means, so we already defined a contour, right? So now we are going to remove material inside that pocket. That is what is called a mill pocket cycle. So inside the pocket, how much material will be there? We will remove it, roughing, bottom finishing, edge finishing, chamfering, etc. That is what is called a mill pocket. Again, we have the parameters like similar to the previous one. Tool name, cutting number, feed, speed, processing, Z0, Z1, DXY, DZ, finishing allowances, UXY, UZ, starting point, XS, YS, plunging, FZ, EP, ER, EW, lift mode, FS, ZFS. The closed contour, what do you mean by closed? Closed contour means if you want to create pocket or island, the contour should be closed. If the contour is open, we cannot do the pocket milling operation. That means the starting point and end point will be same. Okay, the contour should be closed. If the contour is open, we cannot do the pocket milling operation. Okay, the contour should be closed. That is one point. The second point is pocket means the small, the recess, the low, the portion inside uh, the workpiece with some depth. That is what is called like a hole. That is what is called a pocket. So island means during the pocket milling operation, some portions will not be machined. So it will be like uh, you know, it will be like this. Some portions will be like this. Okay, during the milling machine. This is what is called island. Okay, so pocket machining will machine the pocket. It will not touch the island. So inside a pocket, it is having so many islands. Okay, so next we are going to discuss various menu in SHOPMILL. So in this various menu, we have different sections: settings, transformations, subprogram, repeat program, and a swivel plane. Settings, as you already know, we can define some safety. We can define safety distance, right? Then retract plane, feed settings, coordinate settings, machining options, default parameters, etc. So for example, if you give safety distance 5 mm or a retract plane 20 millimeter, it will go there. Transformation means you can no need to write the program again. You can use different transformations such as mirroring, rotation, scaling, shift, pattern, copy, etc. Subprogram means, for example, if you are using one machining n number of times, no need to write the program again. You can save the program separately and you can call that program in main program. So the advantage of subprogram is that your length of program will reduce, editing will be easy, and memory usage will be less. A repeat program means program or a program block to execute n number of times. For example, drilling a hole 10 times. No need to write again. So using repeat program, we can execute this. Swivel plane means you can rotate the machine coordinate plane. You can change the coordinate system and the machine. So for example, normal surface will be like a parallel, right? You can 45-degree surface, you can use swivel plane. Machine coordinate system will change to 45-degree. Okay. So in this settings option, okay, let's see. First, we will see settings option. Okay, so here we can see PL. So what is PL? So PL is what is called a processing plane. So in which plane machining is happening? Okay, so for example, we have G17. G17 means XY plane. G18 means ZX plane, and G19 means YZ plane. So normally in milling operation, the machining will be in G17 plane. Okay, that means XY plane. Then we have RP. RP means retraction plane. RP means retraction plane. So RP means retraction. Retraction plane means once the machining is completed, so tool will go to a safe distance. So that absolute distance is what is called a retraction plane. So after completing the machining, the tool will go to the retraction plane. SC means safe distance. So safe distance means this is a small distance above the workpiece. That is called a safe distance. This is to avoid collision. Then we have a processing direction of rotation. That means downcut milling or upcut milling. So based on the pocket, slot, spigot, it will change the tool path direction. Then next is retraction position template. Retraction position template will be optimized or to retraction. Optimized means, so for example, see, retraction plane optimized means tool will travel small distance only based on the contour. It will save time. Okay. So on retraction plane means after completing the each operation, the tool will go to that retraction plane. So this will be useful if you have clamps or obstacles more. Okay, so this retraction plane will be useful. Next is transformations. Okay, so transformations means we can, uh, for example, the coordinate system or workpiece geometry we can change. No need to write the program again. That cycle group is what is called transformations. That means 0 point offset, rotation, scaling, mirroring, etc. So various transformations will be you have work offset, then offset, rotation, scaling, and mirroring. Work offset, we have already discussed this work offset in the previous classes. So work offset will be. So work offset means this is to set the zero origin. Work offset means this is to define the zero origin point. So we have machine 0 point and we have workpiece 0 point, right? So this point is fixed, machine 0 point. Without changing this machine 0 point, we can change this workpiece 0 point. Normally in shop mill, the work offset will be G54, 55, 56, 57, etc. So we can set the work offset like G54, 55, 56, 57, 58, etc. For example, you have just imagine you have two workpieces, right? In your table, you have two workpieces. Okay. So this is one workpiece two. Okay. So we can set workpiece 0 as 1 as G54 and workpiece 0 of workpiece 2 as G55. G55. So if you select G54, then the tool will come and machine workpiece number 1. If you select G55, the tool will come here and machine workpiece number 2. No need to change the program. Okay, just change the workpiece offset only. Same program you can use just to change the offset. If you select G54, tool will come here and cut this. If you select G55, tool will come here and cut this. Don't change the program, only change the this work offset only. Okay, so then next is offset. Okay, so offset means if you selected work offset, okay, this will be used to give a small shift from the selected offset. For example, if you selected G54, okay, so G54 is so x equal to 100, y is equal to 50. So the offset, you can give offset value as x equal to plus 20 and y is equal to minus 10. So the new offset will be x equal to 120, x equal to 120 and y is equal to 40, right? So this is what is called a offset. So from the work offset, we can shift it. We can shift that point with the help of this offset. Okay, what will be the new x, new y, and new z? So you set the work offset, cancel, and now you set the work offset, right? From the work offset, you can shift the offset. That is what is called a next is called a rotation. Next is called a rotation. So rotation means you can rotate the coordinate axis. You can rotate the coordinate axis certain angle. Positive angle means counterclockwise. Negative angle means clockwise. So for example, rotation, you can shift your coordinate axis, say x. Okay, what will be the new x? Okay, say 45, like, okay, y is equal to 45 and z is equal to 45. So that is what is called a rotation. So no need to change the program. The coordinate system only will rotate. Then next is called a scaling. Another transformation is called a scaling. So scaling means you have coordinates in your program. Using a scale factor, you can either enlarge or decrease. Okay, so machine will multiply the scale factor to all the coordinates. So for example, you have a rectangle of say 100 into 50. Okay, so the scale factor is equal to 2. So the result will be how much? So 200 into 100. So this is the use of scale factor. Okay, or if you use scale factor 0.5, then the rectangle will be so 50 by 25. 50 by 25. Okay, this is for prototype, model making, design verification, etc. So this is scaling. So you can set the scaling factor. What is the scaling factor at xy and what is the scale? Just give a scaling factor. Right. Then next is called a mirroring. So mirroring means you have axis, right? So this is x, this is plus x, minus x, right? This is y, right? So mirroring means based on the axis, you can mirror something. Okay, based on x, y, or z. X-axis mirror. Okay, y-axis mirror. Okay, etc. So x-axis mirror means the geometry will mirror in x direction. Okay, so that means you have a right-handed part. It will becomes left-handed part. This will be very much useful if the component will be symmetrical, and this is for mold manufacturing. Okay, next we will see 0-point offset. Okay. So offset I have already explained. Okay. Uh, so now you have offset G54. Okay. Okay. If you want to shift this offset to a certain distance, you can use the offset option. So the offset type will be new offset. This will give you new offset. That means if you gave offset, it will change. And if you use new offset, it will use the new value. For example, if G54, X value is 100, Y is equal to 50. If I set new offset, so G54 will be X is equal to 20, Y is equal to 10. Okay. If you set this, machine will use this as your new offset value. Then another one is called additive offset. Yeah, this is new offset. Another one is called additive offset. So additive offset means, for example, if your offset is say if your offset is x equal to 20 and y is equal to 10. So additive offset means x equal to 5, y is equal to -3. So what will happen? So the final offset will be x equal to 25 and y is equal to 7. Y is equal to 7. So next is rotation. So rotation means you can shift the coordinate system in any direction. So this will be very much useful when the workpiece is not in correct position. Okay, without changing the program, you can machine it by changing this rotation option. Okay, so you can use this click rotation. Again, here you have uh, new rotation that will give you new rotation angle. It will avoid the old rotation and it will use the new rotation. For example, the rotation angle will be say 45 degree. Another one is called additive rotation. Okay, now you have a rotation. So now the rotation will be 30 degree. And if you give additive rotation 15 degree, then the final rotation will be 30 plus 15, 45 degree. So X, Y, Z parameters, that means rotation based on X axis, Y means rotation based on Y, Z axis means rotation based on Z. Unit is in degree. So positive means counterclockwise and negative means clockwise. Next is what is called scaling. So scaling means in your program you have coordinates, right? Okay. You can use a scale factor. You can enlarge or decrease it. You can increase the size or reduce the size is what is called scaling. Okay, so we can manufacture a particular shape. Okay, no need to write the program again. By using a proper scale factor, you can machine the same shape object geometry. If it will be an increase big size or a small size, but the geometry will be same. Okay, so by using an appropriate scale factor, you can run a particular operation. You can machine one particular operation using this scale factor. Again, you have two options. One is cancel. Okay, go to scaling. Here you have two options. One is new and additive, right? So new means you can give a new scale factor, right? Okay, so for example, if I click new, You can give what is the scale factor in XY, what is the scale factor in Z. Okay. Additive means currently you have one scaling factor. It will add the new scaling factor with the existing scaling factor. Again, XY will be scaling factor on XY plane. Z will be scaling factor in Z. Okay. So for example, if the scaling factor is equal to 1, okay, so the dimension is 100 mm, and if I am using scaling factor 1, the dimension will be same, right? No change, right? If I'm using scaling factor 2, and what will be my dimension? It will be 200, right? You understand? So all dimensions will be changed to 2 times. If the scaling vector will be 0.5, so our dimension will be 100, it will be 50 mm. So this is what is called as this is what is the use of scaling factor. Okay, let's see one example. If I have a rectangle, okay, you are going to machine a rectangle. Okay, so you are going to machine a rectangle of size 100 by 50, and you will be using the scaling factor xy is equal to 2. Then what will happen? So that means the machine will machine a rectangle of size 200 by 100, right? Because this is your scaling factor. So this scaling factor, so our new dimension will be 200 by 100 because our scaling factor is 2. You understand? So by using the scaling factor, you can manufacture, uh, uh, you can use one particular program and you can manufacture different size workpieces. Okay, either big or small. Using the same program, you can increase or decrease the size, and you can manufacture the object with different sizes using the scaling factor. Then coming to mirroring. So mirroring means if you have symmetrical components like left hand part will be equal to right hand part. If you have some symmetrical components, this function will be very much useful. Okay, so mirroring we can do mirroring with the help of based on x, y, or z axis. Again, you have mirroring. You have different options such as new or additive. New means you can add a new mirror setting. It will avoid the old mirroring. And you have additive. Additive means if you add the new settings, it will add to the existing mirroring setting. So you have different parameters. Okay, so you have different parameters x, y, z. That means mirroring will be based on x, based on y, based on c. Okay. So you can either on or off the mirroring. Okay. So which axis you need? You can either turn on or off. Next is called subprogram. So settings I have mentioned, cancel, right? Transformations I have mentioned, right? Then subprogram. So this section I am going to discuss how you can use subprogram and how we can repeat program blocks. So the use of subprogram and repeating the blocks means when you write a program, CNC program, the length of program will be too much. Okay, so a CNC program means it consists of n number of lines. So our aim is to reduce the length of the program. Okay, so that we can use subprogram as well as repeat the block. How you can invoke the subprogram? Subprogram, or we call it as subroutine. So you have a main program. Okay, so right. Yeah. So you have a main program and you have a subprogram, right? So you have a main program and you have a subprogram, or we call it a subroutine. Okay, so this subprogram or subroutine we will be using multiple times in this main program. So the machining steps will be prepared and stored as a separate program. Okay, and this subprogram we can use multiple times in the main program. So that means a machining process no need to repeat again and again. Okay, one time write a program, and then if, whenever required, use this subprogram into the main program. So call the subprogram if whenever required. So each workpiece you have say center drill and chamfer. Okay, if this is same, okay, so no need to write in the main program. Just prepare as a subprogram and named drilling.spf. Okay, and then call drilling. Just in your main program, just call drilling. So what are the parameters required? Okay, so first of all, path or workpiece. You can save the subprogram in the directory where your main program is saved, or you can give the folder path where you saved your subprogram. That is called a path or workpiece. Then program name. Okay, so for example, you should give a proper name to your subprogram. So there you can store the subprogram. You can store the subprogram in SHOPMILL. You can store the subprogram in SHOPMILL, part programs, subroutines, or user folder XYZ. So one of the main point is that when you call a subprogram, in the subprogram, in the subprogram also header will be there, right? That means plane, rotation, scaling, offset will be there. So it will continue in the main program. So best method is after completing the subprogram, you should give the settings in the main program again. So the advantage of subprogram is that here you should give the subprogram path or and also enter the program name. So the advantage of using subprogram is that the program size will be, we can reduce the size of your program. No need to write the same code again and again. Editing will be very much easy and errors will be very much reduced. Then coming to the next one, repeat program blocks. So what do you mean by repeat program blocks? So for example, when you write a program, you have n number of blocks, right? N number of blocks. In some cases, some instructions you have to write again and again, right? So in those situations, no need to write again and again. Okay, one time you will write that block, right? And then whenever required, we will repeat that same block. That is what is called a repeat program blocks. So for example, you have a pocket, okay, machine 10 times. Okay, that means you have to write the code, right? Okay, only one time write. Then you can use the repeat program block option. Okay, so go to, yeah, here you can see where, yeah, here repeat program. So here we have a set mark. Okay, you have to, so some portion you have to repeat, right? You have to set start mark. Okay, so you have to define start mark, program blocks, end mark, and after that repeat program how many times, number of repetitions, how many times. So as per this, in this machine, we can repeat a particular block, say 9 times. We can repeat. We can repeat a block. So the step will be like this. First of all, uh, you have to place your cursor beginning of the block. Okay. And then after that, you have to press this set mark soft key. Set mark. Okay. Then after that, click accept. After that, click accept. So give this as mark 1. Accept. Okay. Give this as mark 1. So this represents the starting of the block. We need to repeat. Then next step uh, is to mark the end mark. Okay. Again, you have to uh, end mark. Okay. So here you can give this as mark 2. Accept. Okay. Now you have mark 1 and mark 2. So mark 1 to mark 2, say 5 times. Repeat. repeat count, say 5 or 10, or as per the manual, 9999. And after that, press the accept key. So the program will execute mark 1, pocket, drill, chamfer, then mark 2. Then it will repeat. So 5 times it will repeat. So because of that, we can reduce the size of the program. No need to write the code, same code again and again. Editing will be very much easy. We can reduce the programming errors. CNC program will be properly arranged. We can save the time also. Next is swivel plane. Next is swivel plane. Swivel plane means go to various. We can change the coordinate system. If the workpiece is not properly straightly aligned, so the workpiece is like there is a small inclination. Okay, if the clamping is not correct, if there is a small inclination, no need to write the program. We can shift the coordinate system and we can machine it. That is what is called a swivel plane. Okay, you can give a swivel plane angle, say 45 degree, then the machine will orient to this direction. So this is not in our machine. So similar to the previous sections, we have the different parameters, swivel parameters. So next is straight line or circular processing. So we can directly use straight line, circle, arc, helix, or polar coordinate. We can create the tool movement. That cycle group is what is called straight line or circular processing. This will be used in basic machining operations, tool movements, chamfering, grooving, edge milling, etc. The straight line or circular processing consisting of tool, straight line, circle center, circle radius, helix, polar, and machine functions. So straight line programming means tool will be moving from the current position to another location through a straight path. Okay, this is what is called a straight line programming. This will be used in milling, edge cutting, positioning, slot milling, etc. Commonly used in shop mill. Second. So let's see tool. We will start with tool. So if you select straight line or circular movement, you have to select tool and also you have to mention the spindle speed. So the parameters will be tool name, cutting edge number, spindle speed or constant cutting speed. DR will be the tool radius allowance in millimeter. So let's see. Straight circle, yeah, this one. Click straight circle and then click tool. So open the tool table and you can create a new tool or you can select the existing tool, give the tool parameter and it will automatically add into the tool parameter. After that, say you can select say facing tool. Okay, so 2000 RPM. Okay, accept. Then straight. So straight means tool will be moving from the current position to another location through a straight line. So for example, straight. Okay. Just enter the values X, Y, Z and uh, feed values. Then we have another one called circle center. Circle center means tool will move in a circular path. Here you have to define the X, Y, I, J and feed value. So X equal to 50, say Y is equal to 50, I is equal to 25 and J is equal to 25. So feed is equal to 100. Then we have a circle radius here. Uh, Here circle center. No need to give circle center. Okay, here you can give what you call radius. Just say 25. Circle radius. Then helix means the circular movement, linear z movement. Combination of circular movement plus linear z movement. This motion is what is called helix. This will create a circular movement plus linear z movement. So this will form a spiral path. So go to helix. Okay, here pitch of helix is say 1.5. Say z is 25. I is 25. J is equal to 25. Helix. Then polar programming. You have a workpiece. You have to enter the radius and x, y, cancel straight polar. Okay, radius and angle. So we can use polar coordinates instead of Cartesian coordinate system. We can program it. So machine functions means here you can provide additional M codes. Okay, so M03, M05, 8, 9, etc. So this is very important portion. Okay, if a tool enters through a straight line, okay, like a straight line or a circular movement, okay, to the retraction area, safely it should move out. Otherwise, when you start the next program cycle, it will hit the other objects. Okay, so collision, there is a possibility of collision. Then coming to the next one, yeah, tool we have discussed. Then next is program straight line. Okay, so program straight line means this is what is called a straight line programming. So this is the current position of the tool. It will be moving to another location through a straight line path. This is for milling, edge cutting, positioning, etc. commonly used. Here we have to give the parameters X, Y, Z. That means that will be the target position. We should give the target position, say 100, Y 100, C say 25. Okay, and the feed will be a feed rate, say 120 mm per minute. So radius correction, left, right, or off. So XYZ I have mentioned. This is the point where tool should reach. Feed radius correction, that means compensation, left, right, off. Rapid traverse, that means rapid movement. Next is program circle with a non-center point. Non-center point means here the control system should know we should provide the circle center point. Okay, so the control system will calculate the radius based on the center point. So these are the parameters we should give. Okay, I'm not explaining in much detail. Then next is circle with a non-radius. From the name itself, it is very clear here. Here we should give the radius value. Then based on that, the control system will itself calculate the other things. Just give the radius values. Then next is what is called a helix. Helix represents the circular movement. Circular plus z-axis movement. So it is shown here. So the parameters will be mentioned here. Then we have our, polar coordinates, right? We have polar coordinates. Normally in CNC programming, we will use XY coordinates. But in some cases, we should give a radius and, angle. So in that cases, it's better to use polar coordinate, using polar coordinates to define. If a radius and angle will be there, we can use polar coordinate system. So in polar coordinate system, first you have to mention the pole. Okay. So pole means it will be the reference point in the polar coordinate system. So all the distances will be measured from the pole. Okay. So for example, this point, what will be the X pole and Y pole? Okay, straight line. So next we have a straight line polar, right? Okay, once you set the pole, we can move the tool using the polar coordinate system. Straight line. Then we have circle polar. Then we have different machine functions, right? Like M3, M4, M5, etc. So that's all from this. So next session, I will start the programming G code. Okay, thank you.